All right, good afternoon. My name is Michael Bagg, and I am a solutions architect with the next generation data center team at NetApp. And what I'm going to today is talk a little bit around the importance of persistent storage and NFV use cases. Before we get started, I'm going to run a little quiz at the end of this in order to give away a $100 Amazon gift card for those of you who are willing to stick it out to the very end of this exciting presentation. So please avail yourself. I'll show this again at the end of the thing, but just in case you wanted to get that part set up and going. So let me fire this up here. And we will get started. So what I wanted to just sort of level set and get started with is this idea that you're not going to approach your NFV environments in the same way that you may have approached your legacy storage requirements in previous lifetimes. You know, once upon a time, you would have established an application, you would have found out that application's requirements or those project requirements. This would have been located in a data center of some kind, and you would have purchased a storage device to put in that data center to satisfy those requirements. It would live behind a firewall. It had a predictable stream of storage that you would be able to, or a predictable stream of data that you were able to meet with that piece of storage. And of course, you had a lot of traditional workflows and methodologies to provide those resources. You maybe had a ticketing system, and you would, when needed to spin up a volume, you would cut a ticket, send that ticket out, and you would have that resource provided. Now, obviously, when we begin to talk about NFV, and as it moves out of data centers into CSOs and MSOs, and even further distributed kind of mechanisms in metropolitan areas, you're not going to be able to do that. The data that you see now is widely distributed. You're going to see it across disparate geographic locations, and particularly when you think about areas like Australia, Canada, North America, Africa, China. More and more of these NFV kinds of pods or locations are going to be even further distributed. The kind of data that you're going to be ingesting into an NFV environment is vastly dynamic and varied. You know, the velocity that you may get from a social stream or media stream is going to be different than that of something coming from healthcare IoT, and it may have different kind of regulatory compliance issues surrounding it. The diversity of data that you'll see, of course, is going to be unstructured, structured. You're going to have block, you're going to have file, you're going to have object, and you're going to have a way to support all of those different kinds of data. The business cases for NFV, where you're going to see NFV beginning to take root, of course, in 5G as we begin to evolve towards 5G away from LTE. You know, a lot of this is being driven by the increase of vehicle telematics, healthcare, consumer electronics, retail, are absolutely going to force the advent of 5G. And you're not going to have 5G without NFV. And of course, if we look at the early days of NFV, the whole point of NFV, of these sort of virtualized network functions or virtualized services, was to be able to provide the capability of being able to use the same resources for different networks. It used to be that a telco, when they wanted to provide a separate network for a healthcare company, what they would have had to done is purchase network hardware appliances for that network. And of course now, with a virtualized environment, you just simply spin up that network on top of the same resources. So you have the capability of being able to reuse and multi-tenant those resources across the same set of environments. And of course, as we begin to see what happens in retail, consumer electronics, or health, are a variety of different kinds of regulatory compliance. When we talk about in the retail, they may have PCI compliance or how they handle credit card processing. And in fact, the example that I have here, we're looking at a donut shop. And this donut shop uses their own private NFV environment to supply the same menuing system, the content that's provided over there. For Wi-Fi, when you go into a donut shop, this particular donut shop, the same Wi-Fi resources are distributed across the nationwide network. It's endpointed at the CPE they have. And then also their point of sales. And they're able to use that same NFV environment, the same sort of distributed NFV pods that live throughout the entirety of their retail operations and franchises, be able to develop that kind of aggregated big data and perform analytics and do things even like surge pricing. Healthcare has had a long history and maturity of how that data is meant to be handled. There's any number of SLAs and regulations around what the content of that data is, how long it can live, who can see it, who can own it. And when you begin to sort of multi-tenant those networks adjacent to one another, you're going to have the same healthcare networks running on top of the same gear that is supporting retail. So you have to have a way to provide that kind of segregation. And I know at a number of the other sessions that I've been attending here at this OpenStack Summit are, they absolutely are developing all kinds of maturity around the performance at the network state, the ability to provide network segregation. But how are you going to do it with the underlying storage? Because the data itself, when we think about what's important to telcos, data has primacy. There's data, and then there's network connectivity. So of course, we see the focus on how networks are being provided and the kind of efficiencies and performance metrics that are around networks, but the same has to be applied towards data. Everybody here knows what NFV is? Yeah, I see at least one person. So the idea of NFV was just the sort of evolution of moving away from sort of hardware-bound services into network-bound services. And none of these devices that we talk about, or none of the services that originated in hardware, really had much to do with data or data management or storage. But now that we're placing all of these devices into a virtualized environment, we're talking about, in most cases, a 3-tier architecture that does have storage behind it. And NFV itself is a source of a lot of data. The data where the usages have data pass through, we're now doing things like putting network taps. So in doing, the origin of a tremendous amount of data. So if you put a network tap behind any one of these pieces of software or pieces of virtualized network services, that spins off a tremendous amount of data. And obviously you're going to have a way to aggregate that data. How are you going to move it from one NFV pod, perhaps replicate or fail over to another NFV pod, or collect and aggregate that to a data lake or a data pool that you're going to further do analytics upon. The other topic that we're beginning to see more and more, and I was at one of the earlier sessions where they're trying to define this idea of cloud edge compute. And when you talk about cloud edge compute, you're really talking about NFV. Because within these cloud edge compute, these kind of NFV, what you're talking about is a distributed network that's moving away from data centers, moving away from MSOs and COs, these central offices that typically only ever held network hardware, are now beginning to hold ever increasingly smaller and granular pods of 3-tier architecture that are supporting these NFV environments. I think Verizon actually showed this very graphic from the NGMN talking about how they're going to slice these services. And really, when you look at this, you're like, oh, well, don't we already do this with VLANs? We have these VLANs that do exactly this kind of slicing. And now you're going to start hearing from your bosses like, hey, man, I need some of these slices. And really, within each one of these sort of sliced services that are being put out are going to be a set of data requirements. And how are you going to manage the data that each of these slices? And again, each of these slices are going to have a variety of different kinds of data flowing and moving throughout. VNF diversity, every network function tenant or service that lives in there is going to absolutely have a different set of capacity and storage management requirements. And what's often missed when you're handing out these kinds of requirements, or if you're a network architect or a cloud architect that's inheriting these requirements from some vendor, whether it's, in this case, it's some PCRF VNF, they're going to say something to you like, oh, well, we're going to need 10 VMs, and each one is going to have some 900 IOPS. So at first blush, you're going to look at this and think, oh, for this pod, I just need something like 20,000 IOPS total. I've got 10 900 IOPS and 2 sets of 1600, 3 sets of 1600. That's less than 20,000. That's a trivial amount for me to satisfy. But in reality, when you sort of unpack and discover that perhaps each I/O for the PCRF is going to be at 64K block size, that's going to tremendously change the requirements that you have for that environment. Because all of a sudden, each one of these is going to be requiring 14,000 4K IOP, right? And that's 10. So all of a sudden, your 20,000 IOP requirement just boosted up to nearly 200,000. Or I guess my math is wrong, 150,000. So there's a little bit of vocabulary that's required when you begin to size and understand the kind of requirements and how you're going to meet those requirements for your environment. And just simple things like block size. When I look at all of these presentations that really talk about how, SRIOV, DPKDK, how they're going to amplify and accelerate their network, it's like, man, I can mess that up quite easily by misconfiguring what kind of underlying storage is there. And the related to this is quality of service. Oftentimes, and I know I did this myself when I first began to work in developing my first proof of concept with OpenStack and my initial kick at the can with VNF, is that the storage was kind of one of my last concerns. I started off with my graveyard set of gear. I threw some OpenStack on it. I landed my tenant. I just used some host-based storage, got it up and running, and proved out my proof of concept. And then, of course, as I began to attract other parts of the company, they began to ask for more resources. I moved off of host-based storage to kind of a centralized storage. I went back to my graveyard, built myself a little storage environment, downloaded some software, and started running that. But the problem is that when you do that, you're going to find yourself unable to provide discrete quality of service for each of those tenants to live within there. And you're going to encounter exactly this kind of problem. And even if you're able to provide some sort of rate limiting or ceiling of performance in the environment itself, as that workload begins to peak towards that limit, it can go and crush other environments that are in there. And this is when you only have this sort of max or rate limited threshold that provides the protection against bullies or greedy environments. What you really want is the ability to set a quality of service that has multi-dimensions, that has a floor and a ceiling. That way you can provide a service catalog. And you can do something like provide a platinum service for those tenants that require a more elevated service for an SLA requirement. And you could also provide perhaps a bronze service or a gold service or lower tier services for those other tenants. This is a real world example, just not a marketing slide. Going back to that sort of PCRF example there, this was before a quality of service was implemented. And again, this is on 10 VMs in 30 sites, which means 300 volumes. And you think about, oh man, I've not configured 300 volumes in my production environment correctly. How am I going to solve that? Well, of course, in OpenStack, you would just create a new catalog entry, and you maybe not platinum, super uber platinum. I guess you just call this one new quality of service. And then you just apply that new spec to the volumes that are running. So it's quite simple to do. And of course, you wouldn't do this with a GUI on a per volume basis. By the time you got to volume 220, you might be a little tired. You would obviously automate this thing. So the idea is that your underlying storage environment, your underlying data management environment is completely automated. And this speaks to this idea that automation is incredibly important. If you're using underlying infrastructure that does not have a RESTful API, you're going to have problems. Anywhere you see a red dot, there is going to be some kind of management and orchestration that fully expects to reach down and either provide some sort of deployment mechanism, some sort of maintenance mechanism, or some sort of operational aspect to storage. And if you have some requirement that means that a human being has to get involved, it's going to be very difficult. So looking for underlying NFVi infrastructure that can fully support OpenAPI is incredibly important, because that's what, if you cannot automate it, it's going to be very difficult. So why NetApp architecture for NFV? Why am I talking about the importance of data management when this is not just storage? The idea that we're going to have an increasing number of environments that you have to support means that you have to have something that's self-healing. That means that if it breaks, you're not going to have, just because of the sheer scale of environments that are out there, the ability to go and break fix with a team of people. You want something that if it breaks, you want to be able to self-heal. In this particular instance, if you have a SolidFire deployment supporting your NFV, if you lose a disk or a node, you're back up to HA quite easily without any kind of intervention. And then you get to send some smart hands out there to either replace the disk drive or replace the node, and you're back up and running. Oh, the acronyms KISS and LOVE. Keep it simple, stupid, and what was the LOV? Loss of valuable energy. You don't want to overburden yourselves by doing things that are not core to the business objective you're trying to achieve. You're trying to provide network services. You're not trying to provide storage services. So, we've solved and made quite simple a number of the storage complexities just go away. Further than that, and I've been talking a lot about the sort of micro scale of deployment at the NFV pod or NFV site per instance and trying to meet the performance requirements of that site. That's fine. What if you wanted to then take the data that's being spun off or aggregated and bring that into a larger ecosystem? How do you do that? It's like, yes, in the example of SolidFire, I can probably meet those requirements with other vendors, and other vendors certainly have products that I can put in to do exactly that. But how do I get them to participate in an ecosystem where you're able to provide a number of services, to have consistent services and well-established means to be able to approach those enterprise data services that you've become accustomed to and use on a regular basis? And NetApp, of course, has a number of portfolio products precisely for that. For the next generation data center, what I primarily see, and I think if you were just here for the previous gentleman that was speaking, the products that I support as a next generation data center solutions architect are these particular SolidFire based innovation. So we have the SolidFire all flash array. This is a flash array appliance that you can purchase that it integrates directly with Cinder. We of course have the FlexPod SF, and this is the SolidFire backed FlexPod, and I'm beginning to see this being considered more and more for a number of the larger deployments for NFV. And I think NetApp HCI is actually a great small form factor that I fully expect to see deployed at these sort of micro NFV pod-like deployments. And I think that pretty much brings me towards the end of what I'm discussing. I have time for some questions before I place my quiz upon you. Go ahead. Yeah, so SDN, I'm not trying to make some sort of a,
Can I say why?
Yeah.
Because all the functions are being delivered in software, and particularly all these functions are network-based, and everything at that layer has to operate in software. So if I could deliver a virtual firewall, a virtual router, all these things. Most of the projects, if you're starting in NFV, is going to be virtual, you've got packet core. So those are the type of projects that organisations first start. And you mentioned the correct point.
That's right. I purposely left off the etsy architecture framework diagram from this deck. You know, what's an NFV deck that doesn't show the etsy framework? Are we all is everybody familiar with this architecture that they're speaking of that has the different layers of where services are delivered and when the infrastructure lives? And I think there's an oversimplification that people just take to heart and feel like, oh, I could just put a blob of storage, and that blob of storage is going to be able to serve all of the disparate needs of what sits on top of that, and whether that's what kind of SDN data that may be floating around just from an operation standpoint. Where do you store the templates and the recipes and the Yang files and everything you're using to produce and control? As well as if you were to do something like put a network tap in, the amount of data that could be spun off by some of these entities is vast. And where and how and what do you do with that data? How do you aggregate it? What kind of services are you going to be able to wrap around that from a data management standpoint to be able to make great use of them?
From the perspective of live migration of workloads, data management seems to be a crystal part. Do you have any view on this?
Yeah, so absolutely. So when we talk about what NetApp has been evolving, and this is not specific to NFV, but of course has great use for NFV, is this idea of data fabric. And the data fabric is this sort of software-defined approach to data management. And you want to get used to this idea of not just having on-prem or cloud, this sort of binary view of the world, but rather a view of the world that is multi-cloud. And when I talk about multi-cloud, I'm talking about a consumption model that means you're going to consume, migrate, move your data the same way, whether it's on-prem, whether it's in a remote site, or whether it's in a very remote, distinct site that may be specific to NFV. You want to be able to consume that data wherever it is, much like a farmer is able to move water to crops that need it, you're going to be able to move data to areas that need it. So yes, we have a strong practice, and we've been delivering this practice and have been moving towards the evolution of this idea for years. Okay, quiz. Let's see how this is going to work. For those of you who have just joined, we are going to do a Amazon gift card giveaway. So right now I only have one player who's going to win, but if you were to navigate to this kahoot.it and enter in the PIN that you see, there's 101398. Let me make sure that it's working. I'll log in myself. Let's see here. Kahoot.it. Really, I only have one player? Is that true? No, you shouldn't have to sign up for anything. It should just be a Kahoot IT. And if I can't get it going, I'm just going to do the traditional plain old raffle, which would be a bummer, because then I can't. Crap. Oh, let me do a refresh just to make sure I'm not getting something like this. Reload. I'll try it one more time. I'm trying to do something fun, and look what's happening to me. Here we go. Let's try one more time. I'll try one more time. If it doesn't work, we'll just. Do you have the bowl of tickets? Are the tickets back there? Somebody? No? Yep, right there. All right. We'll give one more last college try at this. Oh, I see Jacob was able to join. Simon joined. All right. Seems like it's working. All right. I'll give everybody a few more minutes, and then we'll go ahead and get started with this. What's that? Look at that. That's pretty clever. All right. All right. You got 30 more seconds. Anybody still trying to join? Can't join? All right. Let's go ahead and start this. 4 questions. The first question is, what NFV business cases were mentioned? Skynet? Spectre? The DS-1 orbital battle station, also known as... Yeah, yeah. All right. Block size has an effect on kilograms per gigabyte. The drive gets heavier with the larger block size? No? Oh, you have to thin provision it. Well, I'm trying to thin provision myself, but it doesn't seem to be working. Not on this trip, anyways. In this prezo, the acronym QoS stands for quality of sauce. Quality of session? Maybe pretty good. Quality of system? And I think my last question, oh, Jin seems like he's in the lead. NetApp Data Fabric is used for the cloak of data visibility. You like that? No? Storage? All right, I think we have our winner here. Jin, you've won an Amazon gift card. All right, come and see me. All right, thank all of you.